Good morning, students. Since we cannot meet in person, I thought I would make this video to go over the ICE problems we normally work out in class in groups or up at the whiteboard. Before we do this though, I want to point out a couple important things. Don't forget to complete the midterm bonus, which is due tonight. I also extended the video lesson for Chapter 7 until tonight. So if you were getting a late start after spring break, you can still complete this work by tonight. I also want to point out how you can print out the Chapter 7 notes. If you scroll down to the course contents for the final, click on Chapter 7, you can view and print the Chapter 7 notes here, which should be very helpful. The notes have definitions, as well as several examples. And now let's talk about the ICE problems. The first question is list out the elements of the set, the letters of the word Mississippi. So for a set we use squiggly brackets. The letter M is in the word Mississippi. The letter I is in the word Mississippi, which means M and I are two elements in the set. Next, Mississippi contains the letter S. It also contains the letter P. Notice how when giving the elements of a set, if the element occurs more than once, in this case in the word, we only list it once. The set of the letters in the word Mississippi contains the elements M, I, S, and P. For number 2, consider the sets A, B, C, and D, and we're asked to indicate whether each statement is true or false. So looking at A, notice this symbol, if we go back to our notes, means is an element of. So for A, we want to see if 3 is an element of set B. Well, notice the element 3 is in set B, and therefore A is true. Next, 5 is an element of C. If this is true, 5 is in set C. If it is false, 5 is not in set C. Well, set C only contains the elements of 4 and 6, and therefore B is false. For the next several problems, let's review the definition of a proper subset as well as a subset. So going back to the notes, a subset, indicated by this symbol here, of a set A is another set that contains only elements from set A and may contain all of the elements of A. So if B is a subset of A, we indicate this using this notation here. And I think of this as the less than or equal to symbol to remind myself that set A and set B can be exactly the same to satisfy this definition of a subset. Next, a proper subset, indicated using this notation here without the bar under the symbol, is a subset that is not identical to the original set. It always contains fewer elements. So if B is a proper subset of A, we indicate that using this notation here. So all of these are proper subset notations. So first, for C, we want to determine if B is a proper subset of A, which means all the elements of B must be in A, and the two sets cannot be identical. Well, B contains the elements 1, 3, and 5, and notice A also contains the elements 1, 3, and 5, and therefore B is a proper subset of A. C is true. Next, we want to determine if C is a proper subset of A. Well, C contains the elements of 4 and 6, but notice A, it does contain the element of 4, but not the element of 6, and therefore C is not a proper subset of A, and therefore D is false. Next, C is a proper subset of B. Well, again, C contains the elements of 4 and 6, so the elements of 4 and 6 are not in set B, and therefore C is not a proper subset of B. Next, A is a proper subset of D. A contains the elements 1, 2, 3, 4, 5. D contains the numbers 0 to 10, meaning 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All the elements in A are in D, and the two sets are not identical or not the same, and therefore A is a proper subset of D. This is true. And then finally, A is a proper subset of B. Well, A contains the elements 1, 2, 3, 4, 5. Notice all these elements are not in B, and therefore it's false. A is not a proper subset of B. Okay, so number 3, we're given the universal set where all the elements we are considering are 1 through 20, and consider the sets A and B. Notice how we have some new notation here, so let's go back to our notes. For A, we have A union B. For B, we have A intersect B. And for C, we have A intersect B not, or the complement of B. So looking at our notes, we are now talking about union, intersection, and complement. The union of two sets contains all the elements contained in either set A or set B, or in both sets, and we use this notation here. So union means or. The intersection of two sets contains only the elements that are in both sets A and B, and we use this notation here for intersection, which means and. And then finally, the complement of a set A contains everything that is not in the set A. And there are several ways to denote the complement of set A, also referred to as not A. For consistency, we will use a bar over the set. So going back to our ice, we want to determine A union B, which is the set containing all the elements in set A or set B. So it's like combining the two sets into one big set, but we do not list the repetition. So let's go from least to greatest. Let's go ahead and use blue. So we want all the elements that are in A or B. So notice that B contains 1. Let's go ahead and cross it off to keep things organized. Next, 4 and 5 are in set B. 6 is in set B, and therefore it's in the union. So we have 4, 5, 6. Next, we have 8 in set B. Notice 11 is in both A and B, which means it is in the union, so we list the element 11. The same with 12. Next we have 14 in set A, 15 in set B, 16 is in both sets, and therefore 16 is in the union, but we do not list it twice. And then we have 17 and 18 in set A. So all of these elements are in set A or set B. Next we have the set A intersect B, which means now we want the elements in A and in B. So we're looking for the elements that are in both sets. Notice how 11 is in both sets, and therefore 11 is in the intersection. So is 12, and so is 16. So the intersection of A and B is the set containing the elements 11, 12, and 16. Next we have A intersect B complement, which will be all the elements that are in A and not in B. So we want the elements that are in A and not in B. So notice 6 is in A and it's not in B, so 6 is in the set. Next, 11 is in A, but it is in B, and therefore it's not in B complement, and therefore 11 is not in the set. Next we have 12, which is also in B, so it's not in the set we're looking for. 14 is in A and not in B, and therefore it is in the intersection of A, B complement. Next we have 16, which is in A and in B, so 16 is not in the intersection of A and B complement. 17 and 18 are in A, they are not in B, and therefore they are in B complement, and therefore 17 and 18 are in the intersection of A and B complement. Okay, moving along for number 4, we're asked to create a Venn diagram to illustrate each of the following. So for A we have C complement. We want to create a Venn diagram that shows all the elements that are not in set C. So first we create the universal set, usually using a rectangle. Within this universal set we have set C. So let's go ahead and call this set C. So all the elements not in set C would be outside set C, and therefore this shaded region here represents C complement. All the elements not in set C. For B we have A union B, which also means A or B. So we first create the universal set, and then we create set A and B. We do want them to overlap, so we'll call this set A, we'll call this set B, and again we're trying to shade the union of A and B, or all the elements that are in A or in B, which should be, here are the elements only in A, here are the elements in A and B, and here are the elements only in B. So all these elements in the shaded region are in A or B. And then for C, we have A intersect B. So we have the universal set, set A, set B. We want the elements that are in both A and B, which is this overlapping region here. This is the intersection of A and B. And then finally for D, we have the universal set. Again, we have set A, we have set B. We want to shade the set that is A intersect B complement, which are the elements that are in set A and not in B, which should be this set here. All these elements in this region are in A and not in B. So moving on, we have number 5 and then number 6. So for number 5, we're given this Venn diagram where the numbers here represent how many elements are in that particular set. And notice how we have some new notation where we have n of A complement, and so on. Let's go back to our notes and review this notation. This refers to cardinality. And again, there are a lot of notes here that give several more examples, so you may want to print this out and put this into your notebook. So here are several examples of some sketches of Venn diagrams. So now we'll talk about cardinality. The number of elements in a set is the cardinality of the set. Cardinality of set A is often noted using this notation here, n of, in this case, set A. So for A, we want to find the cardinality of set A. Well, here is set A. And notice how there are 15 plus 8 are 23 elements in set A, and therefore the cardinality of set A is 23. Next we have the cardinality of A complement, which is the number of elements not in set A. So all the elements not in set A would be all the elements in this region here. We have 3 plus 21, which is 24. Next, we have the cardinality, or the number of elements in set B. Here's set B. Set B contains 8 plus 21, or 29 elements. Next we have the cardinality of B complement, or the number of elements in B complement. which is the number of elements not in set B. So here's set B. Here are all the elements outside set B, or not in set B. We have 15 plus 3, which is 18. Next, we have the cardinality, or the number of elements in A intersect B, or the cardinality or number of elements in A and B. So the set A intersect B is this set here, the overlapping region of set A and B, and there are 8 elements in this set. Next, we have the cardinality of A union B, which would be the number of elements in set A or set B. So the union of set A and B is this set here. The number of elements would be 15 plus 8 plus 21. 15 plus 8 is 23. 23 plus 21 is 44. And then finally, we have the cardinality of A complement intersect B. So let's first shade the region that contains the elements not in A and in set B. So not in A and in set B would be the elements only in set B, this set here. Again, this region represents the elements that are in the intersection of set B and A complement, or not in A. So the answer is 21. Okay, so for the last example, out of 60 students, 21 are taking English, 34 are taking math, and 7 are in both. Let's begin by organizing the information in a Venn diagram. So we have 2 subjects. Let's call this first set English and the second set math. And we're going to start with the last information that 7 are taking both classes, which means there's a 7 in the intersection of the 2 sets here. Next, we know there are 34 students taking math, so there must be 34 students in the set of math. There's already 7 students here, and since 34 minus 7 is equal to 27, there must be 27 students in this set here that are only taking math. Notice there are 27 plus 7, or 34 students taking math. It's just 7 of the 34 are also taking English. And then we also know there are 21 students taking English. So there are 21 students taking English, but 7 of them are already here. 21 minus 7 is 14. There are 14 students only taking English. So again, notice how there are 14 plus 7, or 21 students taking English. And then finally, we're told there's a total of 60 students. Notice how so far we've accommodated for 14 plus 7 plus 27 students, which is 48 students, which means there must be 12 students not taking English or math, or 12 students out here in the universal set. Again, because 60 minus the 48 gives us the 12, so there must be 12 students not taking English or math. So there's part A. And now let's answer some questions. Next, how many students are taking either English or math? The set of English or math is the union of English or math, which should be this set here. And we have 14 plus 7 plus 27, which is 48. There are 48 students taking English or math. Next, how many students are not in English? The set not English is the set outside of English, which should be this set here. Notice how we have 27 plus 12, which is 39 students. 39 students are not in English. And then for the last question, how many students are in English and not in math? So they're taking English but not math would be the students taking only English, which is this set here, which is 14. Okay, we'll go ahead and stop here. I hope you found this helpful.